Hello and welcome to another edition of Lost in Science across Australia on the Community Radio Network. This is half an hour or thereabouts where we all talk about sciencey things. Who are we all? Well, my name is Stu, and on the show with me, at least partially, I have Chris. How are you today, Chris?
Look, I've been better, Stu. Yes, apologies to listeners. When he says we all talk about science, only part of me is able to talk about science at the moment. I have another cold or one of the other viruses that's going around. Don't worry, I've taken rats, multiple rats. It's all negative so far, but yeah, not doing so great. But we can, science doesn't wait. Science doesn't stop, as you know.
This is one time I'm glad we're not sharing a studio right now. But aside from a nasty virus, what have you brought in to the show for us this week?
Well, I guess I did think that maybe I should be talking about one of the big things that's happening, or has been happening the last couple of weeks, which is the COP27 climate conference. But I feel, the science for that is pretty straightforward at the moment. We're just waiting for the politicians to do their act. We have had reports that carbon emissions have gone up recently, despite the global energy crisis that is believed to be largely due to increase in coal burning. So, yeah, not great news there. So I thought I might turn to look at other planets instead.
And which other planets?
Yeah, I thought I'd look at our neighbours, Venus and Mars, both of which in recent years have had reports detecting gases in their atmosphere that could be signs of life. So it's kind of one of those follow-up reports that, I like doing, because usually the follow-up stories to this don't make the international news as much as the first tentative discoveries. So we're going to do a bit of a state of the play, I suppose, sparked by some new research that's come out recently.
Signs of life on other planets is a great headline, but the minutiae of the science that follows doesn't necessarily make the editor's copy table, I suppose.
Yeah, look, it's not all bad news. Again, life obviously hasn't been confirmed. That would have made the news. But yeah, it's not all bad news. Don't dig a hole just yet.
And in science, all data is useful, right? Isn't that what we like to think?
Yes.
And also on the show this week, I am going to be looking at a story, and people have heard a lot about rats recently, and probably had close encounters with rats. I'm going to be talking about the OG rats. Well, the original lab rats, actually, and I'm going to be talking about some experimental work coming out of Tokyo, or from the University of Tokyo, about, do rats like music?
Wow.
We all know humans like music. We like to get out on the dance floor and dance around and show off our rhythm. But these guys were wondering if rats actually could appreciate music. And more specifically, they're looking at whether they could follow a beat and keep the beat, which is something that, as far as we know, is a human ability. We don't really acknowledge other animals as being able to do that.
Yeah, there's I believe a famous study hundreds of years ago where it was in the town of Hamelin, where a certain Pied Piper demonstrated that rats were indeed enticed to music as much as human children were.
Indeed. I think he was more using the melody to entice the rodents along, as well as the children. But in this case, we're specifically focusing on the beat. But I'll explain what all of that is about later on in the show. So please stay tuned.
Yes, you're listening to Lost in Science, and as Stu has reminded me, there is that Men Are From Mars, Women Are From Venus book that came out many years ago now, which I didn't want to discuss, but let's keep not discussing that.
Look, I put it in your head. I apologise. I apologise for that. But look, as far as men are from Mars, women are from Venus, that's not the life that we're talking about here, is it, Chris?
No, no, and honestly, that always sounded like the start of a dirty limerick more than anything else. But yeah, no, I'm talking about life on the chances of life on Mars and Venus, which are the two closest planets to Earth, obviously, and also the two planets in our solar system most similar to Earth, in superficial ways, I guess. Venus, most of the big figures, is very similar to Earth, but it has this really thick carbon dioxide atmosphere. Oh, there goes that greenhouse effect and global warming again. I should have really worked all this in. It has this temperature is hot enough to melt lead on the surface. So it's often known as Earth's evil twin, whereas Mars is further away from the sun and a bit smaller than Earth. However, it does at least, have, relatively, compared to Venus, relatively benign climate, and is much more seen as a chance for life to emerge. So look, I'll discuss Venus first because that's the shorter story. And then we'll get on to Mars, which is a bit more complicated situation. But so Venus, as I said, the surface of it is too hot for life, pretty much regarded as that. But there has been speculation that there could be life in its upper atmosphere, where the temperature is a bit cooler.
On Venus, Venus is closer to the sun, obviously, as you said. Is the temperature on the surface related to which side is facing the sun? Like, I know on Mercury it gets very hot and very cold. Is that similar on Venus, or is it more of a uniform temperature all over?
Yeah, it's the latter. It's very much a greenhouse effect situation. The temperature on Venus is much higher than it is on Mercury. And it is, like I said, blanketed in a atmosphere that's 90% carbon dioxide, with sulfuric acid clouds. So you get nice acid rain, super acid rain on it as well. And it also has a very long year. It's a very long day. Its day is actually longer than its year. The whole idea of which side is facing the sun, it doesn't really matter. It just doesn't really care about that kind of thing. Anyway, but in 2020, there was some researchers from Cardiff University who found evidence that there was a gas called phosphine, or phosphine, I think. Might be pronounced pH3. It is. That's one phosphorus atom and 3 hydrogens. And they found evidence that in Venus's upper atmosphere using infrared telescopes. The James Clerk Maxwell telescope in Hawaii and the large millimeter submillimeter array in Chile in the Atacama Desert. And they analysed the data and they found there was 20 parts per billion of phosphine in the atmosphere, which may not sound a lot, but it is seen as a biomarker. Like, it's something that could indicate there is life producing this molecule. So it was kind of a good indication that something's going on, and everyone got very excited.
Do we know of any other process that creates phosphine, or is it only, as far as we're concerned, is it only something that's produced by life?
Look, it's one of those things that you can never say never, I guess. And people try to come up with all kinds of theories for how it could be formed. But that's not the story here. The story is that they went back and recalibrated the data and said, we overestimated. It's more like 1 to 7 parts per billion. But some other people investigated the same data and had trouble replicating their results. So recently, some scientists from NASA went up on a special aircraft they've got, the Stratospheric Observatory for Infrared Astronomers, SOFIA it's called, and they had this German device on board, and it's able to get a better view of infrared because it's much sort of higher above the Earth's atmosphere. And they basically weren't able to find evidence for phosphine in the atmosphere using their more sensitive instrument. They couldn't rule it out completely. They put an upper limit of 0.8 parts per billion, which they didn't detect it, but they said, look, this is the best we could detect it. It's got to be less than 0.8 parts per billion. So basically, from their data, it looks like there is no phosphine. Now, sure, other people will do more experiments and look again, but not good news for the phosphine life on Venus theory, which was always a long shot. I think it was very popular with some people who want to send a probe to Venus. Venus was the first planet we sent a spacecraft to because it was the closest, but very quickly stopped going there because it's not a nice place. So a lot of people who say, look, we're neglecting Venus. Everyone's sending stuff to Mars. Let's send something to Venus. This is a good excuse to go to Venus.
Did it actually destroy the spacecraft that we sent? Like,
it's not. You don't want to. Not a nice place.
It's an angry planet.
But that's why there are now plans to do kind of atmospheric probes, like things that would float around in the upper atmosphere and look at the clouds and that sort of thing. We do have orbiters that go around it and look at it, but obviously if you go down into the clouds, you can see more itself. We'll put Venus on hold for the moment. Now Mars, on the other hand, has long been a speculation about whether there is life on Mars. I believe Professor David Bowie speculated. H.G. Wells and Orson Welles had their whole kind of thing about life on Mars, and a lot of different ways of searching for life. But one that's interesting is the idea that there is methane on Mars. Methane is another gas that's seen as a bit of a biomarker. Now, on Earth, methane is pretty much mostly produced by, processes related to life, primarily the decomposition of biological material. So, the detection of methane is a good sign. I should point out that there is methane. There is definitely methane elsewhere in the solar system. If you go to the outer solar system, the gas giants have, levels of methane in their atmospheres. Pluto, I believe, has methane ice on its surface. So certainly methane can be produced in other ways through chemical reactions. However, it's a volatile chemical. It doesn't stick around at the warmer temperatures that you have in the inner solar system. So to detect it means that something must be producing it. Yeah, so they first identified methane in 2004, and then I believe it was in when they sent the Curiosity rover down to have a look, and that has a methane detector on board. I think in 2018 they observed there was a seasonal cycle in the methane levels in the atmosphere. So it went up and down with the seasons, which again is kind of a suspicious thing. Is something going on here? But it's kind of gotten more complicated than that. So what they did, there's basically two machines that recently have released data looking for methane on Mars. One of them is the Curiosity rover, which went into a crater called the Gale crater looking for methane and detected large spikes in the level of methane, sometimes as high as 21 parts per billion, when it's normally around 4 parts per billion or less. But these are only very brief spikes. But meanwhile, there was another spacecraft, an orbiting spacecraft, the Trace Gas Orbiter, which is designed also to look from above at the atmospheric content, and it found much lower levels of methane, basically all the time, and could not replicate the Curiosity's findings. So a bit of a puzzle: is there methane or is there not on Mars? Reanalysis of the data, essentially, or some modelling to figure out what's going on, has indicated that there could be weather effects doing this, so that there could be something releasing methane in this particular crater that Curiosity probe is detecting. I should point out, someone did suggest maybe the probe itself is releasing the methane, but they're able to rule that out. But apparently, the way that the Curiosity device works is it works best at nighttime, and the Martian atmosphere is very still at nighttime, whereas the Trace Gas Orbiter works best in daytime, so get a good look at the atmosphere. And winds start up, and so any gas that may have been released during the night then is dispersed into the atmosphere during the day. So that kind of explains why you may see much less methane from the orbiter than from the rover, and they have done some more kind of modelling and some tests at different times of day to indicate this is a good theory. So they think they may have results on this contradiction, but they still haven't quite figured out what's causing it. Now, there are geological processes that can cause methane. There is a rock called olivine, which is very common on Earth. It's also common on Mars, that can produce methane through chemical reactions. And one of the theories is that as well as, or could be life, one theory is that however the methane is produced, it kind of collects underground in sort of frozen material and then is released, and that's when you're detecting these high concentrations. So that kind of seems like a reasonable hypothesis. It implies that whatever's releasing it is down very deep, so it may be difficult for us to find what's doing it, but does also see the question of where the methane goes. Because if there is these processes releasing it, then there actually should be more methane in the atmosphere than there has been detected. It is a volatile chemical, but it should still have collected enough. So now they're trying to figure out where the methane goes. And there could be some sort of life form, some sort of bacteria that is consuming methane, or it's possible it's getting frozen up again in this geological form. So yeah, we just don't know at this point what's causing it to come and go. But it's looking like at least the data kind of agrees now. So methane on Mars is still an open question. It does appear to be methane. Sometimes it's very high. It's not as high as we'd expect. So we've still got to find out what's causing it and where it's going.
Well, I know you mentioned David Bowie talking about life on Mars, but I also remember the Moody Blues saying that the chances of anything coming from Mars are 1,000,000 to 1. Would you say it's higher or lower than 1,000,000 to 1?
I guess my gut feel is lower than 1,000,000 to 1, but it seems like a lot of money to spend spacecraft going looking for Mars if it's that unlikely. There is a return mission going there, I think in the 2030s, that will bring back rocks. That will, obviously, if they bring that to Earth, we can do more tests. We can look at them better on Earth to find out whether there's any signs of life. But the worry is if it's some processes deep underground, we may not be able to find out what it is until we dig really deep holes.
In the history of science, novel and innovative concepts occasionally arise from sudden left-field inspiration.
But I'd rather be remembered for my own small contributions to science.
As a scientist, I don't want to prejudice my experiment. I'll let you know in the morning.
I am a scientist!
I think they're scientists.
I bring scientists, you bring a rock star.
Across Australia on the Community Radio Network, you are listening to Lost in Science.
Radio signals yet?
Except for a single, very powerful radio emission.
Of course, a transmitter of that sort isn't exactly standard equipment.
Science and technology must be absolutely mind-boggling.
Of course, it's mostly on the theoretical side.
What's so far? Across Australia on the Community Radio Network, you're listening to Lost in Science.
Now, when we think about science and rats, the first things that spring to mind, well, possibly rat tests at the moment, but the first thing that springs to mind with science is probably lab rats, right? I mean, most people would know what a lab rat is, and if you say someone's being used as a lab rat, you know what that means. So they're obviously bred specifically for use in science experiments because they're easy to breed and they're easy to keep. They're small, so you can have a lot of them in a small area, and multiple replications of experiments can be conducted in a relatively small area without much resources and all of that sort of thing. And also, they are mammals, so they're often used in preliminary studies into various things that affect other mammals, particularly human beings, and often lead to further research. But, there's a sort of a bit of a smarty pants saying that, all things give rats cancer. There's only so much you can learn from a rat experiment because they're not actually that similar to us. They're just kind of a sort of model organism that represents a lot of things that we're like and a lot of things that we're not really. So it's very hard to compare the effect of something on a rat to something on a human, and it makes it quite difficult. But one thing about humans, we have an apparently unique ability to keep time. That is, we can recognize a repeating beat and predict it or keep up with it, and this is how bands of musicians can stay in time with each other. At least some bands of musicians can stay in time with each other. I guess that's kind of how they invented jazz, right? That all those guys got together.
I was thinking all those drummer jokes. Yeah.
I'll leave the drummer jokes to the rest of the bands out there. Now it also gives rise to another apparently special human activity, which is dancing. And humans of all cultures have developed dancing as an activity to accompany music, obviously for ritual purposes, but also just for fun because we like going out and dancing. Although, according to some anthropologists, that might be for ritual purposes as well. Not here to discuss that at this point, but the ability to recognize a beat and keep up with it seems a peculiarly human ability. And some scientists at the University of Tokyo wanted to know if other animals could do the same. They were curious to know, where did this come from, this ability to keep time? So their first thought, of course, was, let's have a look at rats. And their question is, can rats dance? Well, that's kind of breaking it down quite a lot to get to what they're actually looking at. But there are a couple of theories about humans and how we, and counting the beat. The first is that it comes from the physical motion of our bodies, and that we recognize beats because we move at that speed. So I know, Chris, you've talked about the natural frequency of walking is about 2 hertz.
Yeah, and when we tried to study how to stop spilling coffee.
That's right.
Yeah.
The right speed to walk at to not spill your coffee. But 2 hertz or walking pace is about 120 beats per minute. And that kind of translates because most popular music is around 120 to 140 beats per minute, and that is cross-cultural. That is not just a Western thing. There's a lot of music that follows that frequency. So this lends some credibility to this hypothesis. We like and recognize music that matches the way we use our walk, if you like. And this leads to the idea that other animals would prefer music that matched their natural rhythm. So smaller animals like rats, for example, would prefer faster beats, potentially. Rats scurry around very quickly and they move very rapidly compared to humans. So, a smaller animal would like faster beats. The other theory that they have is that our musical recognition is actually dictated by the speed of our thoughts, or at least the patterns, the rhythms of our brain function, which are less changeable between species. Our brains kind of function at the same speed, regardless of what kind of mammal you're looking at. You've got, mice and humans and elephants all kind of think about the same rate because the brains operate in the same way. So to test these hypotheses, the scientists took some rats and observed and recorded their behaviour in a number of ways, including using accelerometers to measure their head movements, so they could, keep track of it.
When they're nodding along to the time.
Yeah, basically they sort of attached accelerometers and looked for the bobbing of the head. And they compared observations of rats to observations of human subjects exposed to the same pieces of music, and they compared the results. And they also had filmed a lot of activity as well. The first thing they found was that accelerometer data matched visual observation data as recorded on video of both human and rattus subjects. In other words, you can see people and rats nod their heads in time with music. So they went to all this trouble of fitting accelerometers to rats and measuring them when they found that, you can actually just watch them bob their head in time with the music, which I found quite amusing myself. They did also find, with rats, it's easier to see them nod their heads if they're standing on two legs rather than on all fours, which is quite, interesting. If they're standing up and leaning on the wall, you can see them nodding their heads a bit better than if they're on the ground.
Holding a pot in their hand.
Yeah, that's right. Standing up the back with their arms folded. But they also discovered that rats synchronized their beat recognition most with music between 120 and 140 beats per minute, just like humans do. So what they concluded was that the beat preference of humans is more to do with brain function than with bodily rhythm functions. And it may be that a much wider range of species is capable of recognizing beats and rhythms in music and other rhythmic sounds than just people, which is what had been assumed up until now. It was also noted when they were doing this experiment that this ability was innate and spontaneous, because what they noted was that the rats used in the experiments had not previously been exposed to music or conditioned to respond to music in any way. So this is an inbuilt instinctive response to the rhythm. And, the fact that humans have only had music for a fraction of the existence of life on Earth, it does kind of suggest that, we've always had the ability to recognize rhythms and beats. It's just that they weren't around for us to respond to before we started banging rocks together or whatever it was that started the musical revolution.
So it's kind of a Footloose situation. These were rats that were raised in the Footloose town. They never encountered music, and then the Kevin Bacon rat comes in and exposes the music, and they all learn to dance.
Yeah, I don't think music was banned in Rat Town, but it maybe is time for them to bust out and cut Footloose themselves. And that is all we have time for this week on Lost in Science. Thank you for joining us in Getting Lost. If you have any questions or suggestions for the team, get in touch with us by email. We are lostinsci@gmail.com. You can send cheap tweets to us at lostinscience1 on Twitter, or you can find us on the ubiquitous Facebook. Lost in Science is recorded at the studios of 3CR in Melbourne on the land of the Kulin Nation and is broadcast across Australia on the Community Radio Network with the assistance of the Community Broadcasting Foundation. You can find a podcast version of the show on 3cr.org.au, or you can tune in the way you did this week when we return in our usual time slot to get Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.